When you're thinking about cabling for your building, it's critical to understand the place of fiber optic cable. So grab a cup of coffee and let me help you become conversationally competent on fiber optic cabling. Well, let me start off with the first question. Why do we use fiber optic cabling? This stuff. The main reason, number one reason, is because of distance. When you're cabling a building, Ethernet cable can only go 100 meters. So oftentimes you'll have a major part of, let's just say you have a really large building right here. You'll usually create a room in that building called the MDF, where all your network equipment and everything else goes, right? And if it's a really large building, Ethernet cable can only go so far. That is 100 meters from that. So you'll build secondary rooms, or sometimes just a box on the wall, that you'll call the IDF, the Intermediate Distribution Facility. You don't need to know that, but you'll connect these two with fiber optic cable to go the distance, whatever distance that is. I'll just put distance. And then from there, use Ethernet cabling and all these IDFs to reach out to each one of them. Now I'm talking within a single building, so these would be your fiber links right here, right? Going the distance between the switches. But this is also valid when you start moving between buildings. This could be crossing roads. Exactly how far can fiber go? Well, it depends on the type of fiber that you buy, which is my next topic, and how much bandwidth you plan to use across that fiber. These two, in each hand, are both considered multi-mode fiber. And when you come back here, you see that there's two types. Multi-mode fiber is a little easier to work with because the core of it is plastic. It actually uses LED lights to send the signal inside of these cables. But that means that even though it's nice and easy to work with, the distance it can go is 500 meters maximum. 300 meters if you're sending high speed, meaning 10 gigabits per second or above. So if you have the need for speed and a lot of bandwidth for now or for the future, multi-mode is often not the way to go. And I would tell you that if I were to be a prophet, I would say someday, I don't think multi-mode will exist. I think everything will go to single mode. Single mode, the cable, it used to be way more expensive, but now it's about the same price as multi-mode. But the equipment that you connect to single mode is usually a bit more expensive. Single mode is glass inside of it, which means instead of 500 meters maximum, you can go miles and miles and miles, right? Regenerating that signal unlimitedly. That's why they literally use single mode under the ocean to bridge continents together. That's the kind of stuff that we're talking about. So single mode uses glass and lasers instead of LED lights to communicate. Now, the only reason that's relevant is to know that things will be a bit more expensive. And when it comes to single mode fiber, you also have expensive equipment used for splicing. That is, when you're using single mode cable, oftentimes you'll buy them pre-made, right? To where you've got a certain length, let's say 100 meters, 200 meters, 500 meters, right? Pre-made cables with ends on both sides. Now, that doesn't always work, and sometimes when you're going through conduit and things like that, it has to be a certain length. That's where you'll need often very specific skill set wise and pricing wise equipment to splice it. That is literally to cut the cable and either join it to another cable or connect some tips at the very end of the cable. That's where you need a fiber specialist to work with. Now, that can sometimes be so expensive that people just choose to buy a nice big old spool of single mode fiber or even multi-mode fiber with the ends on there, and they just, maybe they only needed 200 meters, but they bought a 500 meter spool and just leave a bunch of it wound up sitting in the ceiling, right? That's a thing. So when you're thinking about cabling your building, think about, it may just be cheaper to buy a pre-made cable and leave a bunch of extra behind. Last thing that I would want you to know about fiber optic cabling is these connectors are varied. It's not like Ethernet where it's like, hey, that's an Ethernet jack. Click, it goes in there, right? You're done. There's only one kind of connector. When it comes to fiber, there's many different types. There's like 8 common types of connectors, 2 or 3 that you see just about every single day in the field. This, for example, is one of the most popular types of connectors. It's LC, right? This is what typically plugs straight into a switch. And if you've got a switch going to another switch, most often it's going to be LC to LC. When you're cabling a building, you often will, if I were to expand this out and get it a little bit into the grid, let's say you have the MDF, there's your switch, and you want to connect it to a switch over in the IDF, right? Well, you'll usually run that into it's called a fiber patch panel, just like a patch panel for Ethernet, same exact function. But oftentimes, this little short cable will be LC on one end and perhaps ST on the other. That's another kind of common connector. And you might say, well, why do they have different kind? Well, they have different kind of functions. Like the ST has little screw-in tips that makes it a little more secure. So when you're working with a patch panel, sometimes a little more stable if you're using a connector like that. The reason I want you to know about it in this, being conversationally competent about fiber optic cabling is missing these, not ordering these, can lead to unnecessary delays in your projects, and oftentimes extremely high-priced purchases because you're trying to get it overnight to meet some sort of deadline. So when you're looking at all the things involved, you're going to typically have a small little fiber patch cable, which is a small connector between the patch panel and switch, a long run, this will be that long distance between the buildings or between the rooms, right, going to another patch cable, so that's your long, just straight connection, then yet another patch cable that goes from that patch panel to the switch over here. If you don't know and you don't lay out that diagram and plan for it, like I said, you can often have long delays between there. That's the tip of the iceberg, but enough to allow you to ask some of the right questions and be conversationally competent when it comes to fiber optic cabling. When it comes to fiber, this is the way.